This conference will now be recorded.
Okay, so this we have done yesterday, which was four-wheel robot, and it was going automatically forward, backward, left, right, as discussed. Now we'll make it a wireless robot. But before we go ahead directly to the wireless one, first we are going to start with the RC, which is called remote control robot. Okay, I am recording the session. That does not mean that you will receive the recordings for the day because of few limitations today we can't share the recording. So I request each and everyone to be here and attentively join the session. Try to learn the things in between. I'll share each and every code today and the circuit diagram as well. Okay. So parallelly, you don't do any practice for now. Just focus on what I'm doing. And in between, if you have any questions, you can ask. So let's start with, let's start adding few buttons here to make it a RC car. So I'm simply searching a button here. Okay. And dropping it to this side, PD0, PD1, PD, not PD0, PD1 I'm saying right now, just drop four buttons and now let's connect it. So I'm connecting them with suppose PD2, PD3, PD4 and PD5. So now if we check the pin diagram of the UNO, which we have discussed yesterday also, PD0 is pin number 0, PD1 is pin number 1, PD2 is pin number 2 and PD3, 4 is 3, 4 respectively. So that means we have connected four different buttons for now, which are connected with pin number 4, 5, 6, 11 of this IC and 2, 3, 4, 5 of UNO board, right? And now if I connect the power to this terminal, why we are connecting the power to this terminal? Because what exactly we want to do now, what we want is that when we press this button, it should give the logic to the IC. And according to our program, IC has to perform the operation of going forward, backward, left, right. Correct? So we have defined the buttons like first button is forward, second button is backward, third button is leftward, and fourth button is rightward. So this way we are doing it. Okay. So that's why I have connected the power to this terminal because these button has to provide the logic to the IC, and if they has to provide the logic to IC, obviously they must have the power source. So that's why we have connected the power source here. And the pin numbers we have used is respectively 2, 3, 4, 5. 2 is for forward, 3 is for backward, 4 is for leftward, and fifth is for rightward. Okay. I'm not starting a very new program for this. We'll continue from the last one itself, right? But I'll create a new file and copy the whole code. Yes. So this was the code which we already done yesterday, and these were the connections for the motor, right? MLP, MLN, MRP, MRN. So now we will add four buttons. So let's say int F equals to 2, D equals to 3, L equals to 4, and R equals to 5. So F, B, L, R mean forward, backward, left, right. And all these buttons are going to act as the input because the pins which we have connected to the IC are going to receive the logic from these buttons. So obviously these pins are going to work as the input pin. So let's say pin mode F comma input. And then let's copy it and paste it four times. Now what we say F, B, L, and R. So this way, all four pins are defined as input. Correct. Now the next point is that earlier we have already used a digital write command, but today it's about the reading. Today it's about the reading because whenever we press the buttons like F, L, B, R, obviously we have to receive the logic, and to receive the logic, obviously it's a read command. So yesterday was the write command, but today it's read command. So first let me write the syntax for the read command, how it works. So the read command is digital read and variable. Simply. This time you can't say variable comma 1 or variable comma 0 because you can't say what exactly we have to read from the button. So we will say simply digital read variable. When we write the logic, it was digital write a variable comma either 1 or 0. So if we have connected the variable like motor or LED, so that time we were saying either turn on the motor or turn off the motor. But today when we have to read the logic, when we have to receive the logic, we cannot predefine what exactly we want to read. We have to simply say just read the logic whatever button or sensor is providing. And the topic which we are doing is RC car. So it is not only going to cover the button interfacing, but also it will cover the sensor interfacing, but all digital sensors. Digital sensors mean who will give the logic of either 0 or 1. That means a kind of sensor which will give you the logic 1 or 0 only. For example, IR sensor which will tell you the obstacle is available or not available. LDR will tell you the light intensity is there or not there. I mean darkness or lightness, so something like that. So we are doing two different topics at the same time for now. Okay, let's come back and add the commands here. This was the code for forward, so I'll do it later. But for now, we have to read all the buttons. So I'll say digital read and read F. Then obviously when we will read this digital value of F forward, we will have to store it somewhere. So I said F value equals to. So I used one variable to store the value of whatever we read from the forward button, right? But this variable is undefined. So earlier we have used these variables and we have defined them as integer data type. Then we use these four variables today, and these are forward, backward, left, right, but we define them as an integer. But if you use this FV, definitely your program is compiler is going to give the syntax error that FV is undeclared. So we need to define the data type for this variable as well. So let's say int fp. So int fp means fp is a variable, data type is integer. So now it is called user defined variable. Same ways, let me copy the whole line. We have to read all four other buttons. So first button was forward, second button is backward. So let's read the backward. Then let's read the leftward, and then let's read the rightward. Now this is also important. If you read the value of f, you store that value to a variable fv. Now, when we read the value b, so obviously we need another variable. So I say bv, lv, and rv. Fv is for forward value, backward value, leftward value, and rightward value. And that is for button according to the buttons we have used. Correct? Now, the next part is obviously what we want. Whenever we tap on this forward button, this must give us the forward motoring, and whenever we press this backward button it must give us backward motoring, right? So for that obviously we need to start comparing. When fv is 1, then do the forward operation. When bv is 1, then do the backward operation. Correct? So whenever we talk about the conditions, obvious it's if else. So how we use if else in this embedded C++, let's try to understand that syntax first, then we'll come back to the main program. So if condition 1, then we have to start the code and write our statement 1, right? So what exactly we said, if you have only one condition in your program, you can write in this way. If your condition is true, whatever is your condition, then it has to run this statement. But suppose if you have two conditions, so how you can write it? If condition 1, statement 1, and then else if condition 2, and then statement 2. So what does this mean? This means if this condition is satisfied, it will run this statement. If the second condition is satisfied, then it will run this statement. Correct? You don't have to terminate the conditions, because if you terminate the conditions, it will not run these statements 1 and 2. Correct? Now, this is the small example when we have only two conditions, and it's not always mandatory to use else if, because right, like your second condition is true if condition 1 is false. I hope you're getting my point. See, you have only two conditions, right? Condition 1 and condition 2. So your compiler will run the condition 2 only when condition 1 is false. If condition 1 is true, obviously it will not check the condition 2. Got it? So what I mean to say, if your condition 1 is false, then it will run condition 2. So if you want, there is no need to write condition 2 in this way. Okay. But you can say, if condition 1 is true, then run the statement 1, or otherwise run the statement 2. Otherwise mean it is now understood that condition 1 is false. So we have to run the statement 2. So if it is not mandatory to write the second condition, the else is going to define it automatically. It is well understood to the compiler. But if you have more than two conditions, let's say three conditions or four conditions, then it is strictly that you need to write each and every condition. The last one may be else, but before that, you need to write all other conditions. So let's take example. Suppose you have four conditions. So what we will say here, else if condition two and then statement two. Then we will say else if condition three and then statement 3, and then we will say else. Now the fourth condition, correct? So for the fourth condition, what we can say that it is else statement 4. So now what does this mean? If condition 1 is true, it will check one by one, right? So first it will start from the condition 1. If condition 1 is true, then run the statement 1. If condition 2 is true, which means condition 1 was false. So now it is checking condition 2. So if condition 2 is true, statement 2 should be there. If both the conditions are false, condition 1 and condition 2, then it will check condition 3. If it is true, then it will run statement 3. But if all condition 1, 2, 3 are false, that means it has to run obviously the statement 4. So else mean understood that all three conditions are not working or all three conditions are false. And even if you want to write the condition, that's your choice. There is no problem. You can write the condition as well. So now it is very clear. If condition 1 is true, run statement 1. Condition 2 is true, run statement 2. 3, 3. Condition 4, statement 4. Correct? So this is the syntax how we write if else in embedded C++. Now let's come back to this coding. What we have said, FB is the data which we will read from button F, BB from button B, LV from button L, and RV from button R. So now let's write the condition. If FB equals to 1. Why we use double equals to? Because whenever we have to compare the data, we use double equals to. And when we use the single equals to like this, it means we are assigning the data. We are assigning the data. For example, if you say a equals to 5 and a equals to 5, what does this mean? Now here you said a equals to 5 and here you said a equals to 5. So in this case, you are comparing. What you are comparing, that if the value of a is 5, correct? And here you are saying a equals to 5 mean you are assigning. You are asking your compiler to assign the value of a to 5, but here you are asking your compiler, does a equals to 5? Correct? So it's a kind of question, but it's a kind of statement. Now come back. So here we use double equals to because we are comparing. And what we said, if the forward button is on, then run the forward operation. So forward operation code is already there. Okay. And also we are not using the delay for now because we said until we hold the forward button, it should go forward. Until we hold the forward button, it should go forward. It's like a joystick, right? In RC car or in your wireless robot, in your wired robot, you have a joystick connected with your robot, and when you tap on the forward button, it's continuously going forward, but as soon as you receive the button, it stopped. Something like that scenario we are creating. So delay is not required in that case. Now, next condition is else if, and it is BV equals to 1 backward, and then let's stop it here. Correct? After this, remove the delay. And then next condition is else if LV. LV equals to 1. LV mean left, and the code is already there for the left one. This code. Let me comment it inside the block, right? And it is what? It is left code. And then let's close the bracket and then comment the delay also. Then we have next condition as right. So else if RB equals to 1, and we said go right side and stop. I mean close the bracket and then remove the delay also. Now the last condition, because we have only four buttons and stop button is not there. So what we want, whenever we release any button, that means if any of these conditions are false, it has to run not any of these conditions. If all of these four conditions are false, it has to run what? It has to stop the process. So let's say else start the bracket and then close the bracket, right? So delays are not required here. So let's comment the delay. Got it? So I'll repeat the process, what we have done. We said if forward value is equals to 1, move the process forward. If BB equals to 1, it's a kind of backward motoring. Then it's left, so left motoring. If it is right, so it's right motoring. And if all these conditions are false, stop your motors. Correct? So now let's save the code with the new name because yesterday code was P4. So now we'll make it P5 and let's export the code. And let's come back here. I'm saving it with a new name. I'm saying it P5 design. Okay. And now we need to upload the code. So the process of uploading the code is double tap, browse, and go to your location wherever you have saved the code. So we saved the code in the folder of Robo Workshop. There we have P5. Just now we save this, but a hex file is not generated. So might be during the compilation, we have errors in the code. No, there are no errors. It's still compiling. So once the compilation is done, then only we'll be able to see the hex file. Now we may switch to this window and here we have the hex file. So let's open and all the things are already set. Now click OK and click play. So now we can see that the simulation is in the play mode. So I'm doing it forward. So it's going forward. Correct. Now, when I release the button, it should stop automatically, but unfortunately, it's not stopped. Actually, what we have done in the program is absolutely fine because we have said that if forward is not, if this condition is not satisfied, even this is not satisfied, even this is not satisfied, even this is not satisfied, then it has to run the last code, and that is obviously to stop the robot. But if here we see, it's not stopping the robot, and the reason is because if you focus on these four pins which we are using for buttons, they don't have any logics for now. They don't have any logics. It's neither one nor zero, right? And what does else mean here? Else mean that RV is 0, LV is also 0, BV is also 0, and FV is also 0. But actually, it's not 0 for now. It is null logic. How I identify this? Because of the color gray. So whenever you see the red color, that means the logic 1, and the blue color, that means the logic 0. But when you see the this color, gray color in the simulation, that means the logic null. So when you tap on the switch, it's giving the logic 1 to pin number 2, and forward button is on, and if the forward button is on, obviously the motor operation is forwarding. But as soon as you release the switch, there is no logic in bed pin number 2, PD2, right? So if there is no logic in at pin number 2, so none of the statement would be satisfied, and no, neither your forward, backward, left, right, nor your stop. That's why it's not stopping the simulation. So what we need to actually do for this, we need to connect the ground to get the logic 0. So if suppose we connect the ground like this, because it was not having the predefined logic 0. So now if I connect the ground here, so all these pins will have the logic 0 now, like this blue color, right? But now there is a problem because we have connected the ground. So if I tap this button, so this the logic will the logic 1 will travel through this button and it has to reach to which pin? Pin number 2. But it won't reach to pin number 2, it will directly go to ground. Why? Because whenever we current travel, it always choose the shortest path to travel. It always choose the shortest path to travel. And what we are doing here, that we connected the ground directly. So whenever you tap on the button, so by tapping on this button, logic 1 will travel through the button, but it won't go to pin number 2, it will simply go to ground, right? And if it goes to ground, pin number 2 does not receive any logic. That means your forward motoring is not going to happen, not even backward motoring, left motoring, or right motoring. So we have to actually connect the ground, but directly we cannot connect. So let's delete this. And what we are doing for now, we will have to connect the ground using the registers. That is called pull down concept. Okay. So what we are doing now, connecting the registers. Why registers? Because as I said, current always choose the shortest path to travel. But more it's not only about the shortest path. Current also look for the minimum resistance value. So wherever it sees the uh, maximum resistance or amount of resistance is there, it will not follow that path. So that's what we are doing here. Now we are creating a complicated path for the current to flow. If it has to reach to ground, then it has to obviously follow the resistance, and current use the law that it won't follow the resistance path if there is any other alternate path which has minimum resistance. So for now, we have two different paths for the current to flow through this button. The first path is to go to pin number 2, and the second path is to go to ground. But ground has the resistance, so it won't directly go to ground. So it will go to pin number 2. Once pin number 2 receive the logic 1, the condition is satisfied, and you can see the motor operation that is forward. Same ways, backward, leftward, and rightward. But when you don't tap on any switch, that time pin number 2 or 3 or 4 or 5 are directly connected with ground. In between, there is a resistance, but they don't have any alternate path because that time the buttons are open circuit. And if there is open circuit, current has only one path to travel, and that path is the ground path. So that's how pin number 2, 3, 4, and 5 will receive the logic 0. And once it receives the logic 0, obviously your robot is going to stop. Okay. Now let's check it. When I tap on the switch, it's forward motoring. Pin number 2 is receiving logic 1. That's what we can see, the color red there. And if I release it, now pin number 2 is logic 0. Pin number 3, 4, 5 logic 0, which means else case is satisfied. And if else case is satisfied, your motor is not happening here. Now if I see backward, it's working fine backward. If I say leftward, it's working fine for leftward as well. And if I say rightward, it's working fine for the rightward as well. So I'm done with this remote controlled car, and it's working absolutely fine. So now if we have any questions, you can ask me, or otherwise we will jump to the wireless robot, which we discussed right now. If you have any questions, you can unmute and you can ask. Okay, fine. I guess there are no questions. So let's jump to the next topic, which is serial communication and serial communication, where we have to make this a where we have to make a wireless robot. But before we go ahead, let me share the code with you guys. I'll stop sharing my screen for now because I'm sharing the code into the group. It's done, right? Now let's go to the next part. Okay, so as discussed, now we'll be doing the part of serial communication. So let's do serial communication to make the wireless robot and even to connect with the Bluetooth or Wi-Fi or GSM, GPRS or Zigbee module. This is very important to understand the serial communication part, right? For this, we have pin number 0 and 1. So pin number 0 and 1 are for serial communication, where pin number 0 is receive pin and pin number 1 is the transmit pin, right? Pin number 0 is the receive pin and pin number 1 is the transmit pin. Got it? Now, if we see here, in this circuit diagram, here we have PD0, which is RX pin, RX mean receive pin, and PD1 is TX pin. So as I said, pin number 0 is set for the receive and pin number 1 is set to the transmit, right? So let me create a small new circuit to understand this serial communication, right? Then we will come back to this robot again. Okay. So for now, I'm going to pick at Mega 328 P again and crystal and capacitor. Let's drop them. So at Mega 328, crystal at pin number 9 and 10, along with two capacitors, where it should be negative pin, positive pin, sorry. So let's rotate it 180 degree. Now it is positive pin. Another capacitor. Let's short them together and connect the ground. Okay. Also, we need to change the value of these capacitors to 22 picofarad. Okay. If you make any mistake, small mistake in simulation and the output is working, that's fine because It may happen with the simulation sometimes, but when you work with the hardware, it's mandatory to use the same configuration, which I'm telling you right now. Okay. Next. Now, what I said, we need to understand the serial communication topic. So, see, for serial communication, as I said, pin number 0 is for receive and pin number 1 is for transmit. Although we also know that pin number 0 to 13 we have for digital input and output pins. So, those are GPIO pins, general purpose input output pins. But other than that, these pins have other feature out of these 14 pins, pin number 3, 5, 6, 9, 10, 11 we use for analog, right? I told you yesterday also, pin number 0 to 13 can be used as digital input as well as digital output, read and write. Pin number 3, 5, 6, 9, 10, 11 can also be used as analog output, right? And now, when I'm talking about this pin number 0 and 1, which can be used for receive and transmit as well, right? So, what are the commands when we work with the receive and transmit? The very first command is serial dot begin. To initialize the serial communication, we write serial.begin, and here we write the baud rate. Baud rate is the data transfer rate at which speed you are transmitting your data from Arduino or Atmega 328 IC to the Bluetooth module or to the Wi-Fi module or to the GSM module, right? So that is called the baud rate, data transfer rate. So we have different options for baud rate like 4800, 9600, and 19200, 38400, and 115200, and many more, right? What does that 4800 mean? That means 4.8 kb per second of the speed. Okay, so whatever baud rate options you have, you just need to divide those values by 1000 to get the speed in uh, kbps. So it's 9.6 kbps. Okay, kbps, and that is more than enough to transmit the data because we are not going to transmit the data like a movie or the big size file. We have to transmit a small amount of data, which is kind of one or zero or A or B or C, something like that, so that we can operate the robot in different directions, right? So for us, these values are more than enough. So I said you need to divide the values by 1000 to get your speed in kbps. So if we divide this 19.2, 38.4, 115.2, right? So that is the command to initialize your serial communication where you set your pin number 0 and 1 for receive and transmit. That means now your board understand, your IC understand that you won't use these pin number 0 and 1 for digital read or digital write operation because now you are using those pins for serial communication, right? After this, whenever you have to transmit the data to serial, the simple command is serial.print and whatever data you are transmitting. Your data must be defined data. Defined mean if you are saying hello, so you have to enclose it by double quotes, which is a category of a string, right? Because data is not predefined value, so we are making it double quotes so that it can understand what actually we want to print. After this, when you have to receive the data, this was transmitting the data from your IC. Now, when your IC or your controller want to receive the data, the command is serial.read. This time you can't say that what exactly you have to read. See, when we use this command digital read, here we say read from variable, but we didn't say what we have to read. Maybe one, maybe zero, depends upon the sensor or a button, whatever they are passing. But here, when we say serial.read, here we not even need to write variable. Why? Because serial.read only have one pin to read the data, and that is the receive pin. And this command already know that it has to read the data from pin number 0. Correct? And the same, when we say serial.print, we didn't set which from which pin we have to transmit because it already know that TX pin is the transmitting pin, so it has to transmit the data from pin number 1. That's why when we use pin number 0 and 1 for serial communication, we are not even required to write pin modes for those pin because this command is enough to understand that we are using pin number 0 and 1 for serial communication. Correct? So now we have three commands to initialize the serial communication, serial.begin and serial.print to transmit the data and serial.read to receive the data. Moreover, there is one more point that whenever we want to read the data, first we need to check whether data is available or not, right? It's not like that your controller will put too many efforts to read the data every time, every second, every nanosecond. No, it will say whenever the data is available in a queue of pin number 0, I'll receive it, right? For that, we will write a condition that is if serial dot available is greater than null, then read the data. Okay, so the meaning of the command is when the data at serial port is available, which is greater than null, then it will read the data. Now, obviously, whatever we have to read, obviously, we need to store it in a variable. Like here we did, when we have not here in this program, I guess we did. When we read the data, we store it in a variable fv, bv, lv, rv, right? So here also, whenever we read the data, we need to store it into a variable. So let's say I'm storing it in a variable, say v value, right? But v is undefined, so we need to define the data type for this v as well. And the data type is not int this time, because you are going to receive the data from third party source. And third party, whenever we receive the data from third party, like a Bluetooth, Wi-Fi, GSM, it is not integer. It become character. Whether you transmit 10 or you transmit AB, always we receive the data in the form of characters only, right? So we need to write character char v serial dot read. That's it. So these are the four commands which we need to understand for serial communication. So now let's come back to this. Here we will use one terminal which is called virtual terminal as a Bluetooth device so that we can understand how we transmit and receive the data. How to find this virtual terminal? If you click on the P, you write virtual terminal here, it won't be visible because virtual terminal option is here on the left side. So you have to click on this icon, which is instruments, and here we have virtual terminal option. So let's drop it here. Let's mirror the image. Okay. So here we have almost four pins: receive, transmit, RTs, and CTS. Now, in real time, if I'm talking about a Bluetooth module, suppose HC05, the Bluetooth module name is HC05. So it also has four pins majorly. The first is receive, then transmit, then 5 volts VCC, and then ground. 5 volt and ground we connect to power up your Bluetooth module, and receive and transmit, obviously, to receive and transmit the data. Correct. So the very first program with serial communication, which we are going to do, is to transmit the data from the IC to Bluetooth module. Correct. So obviously, when it has to transmit, we will use the transmit pin, and we will connect this transmit pin to the receive pin of your terminal. Never ever connect the transmit pin to transmit and receive to receive, because it will collapse your data, right? Data may lost because of the one way and because of accident. So what I'm saying, if you are transmitting the data from this IC, use the transmit pin, and in that case this Bluetooth module is going to receive the data, so connect the receive pin here. Now we are done with this, so let's come to the coding part and create a small code for this. So what I'll say, simply I'll say serial dot begin. It's 9600, 9.6 KB per sec, and serial dot print. What to print? I'm saying print hello from NC. Okay. And now when I'm printing it, obviously this hello from NC is not predefined. So let's put in a double quotes, make it a string. Done. Now let's save the code in the same folder I'm doing it, and with the name T6. Okay. Let me export the file. Let's double tap here and browse the file. The file is available in the folder P6. Still compiling, I guess. Yeah, it's done now. So P6, and let's make all the settings to unprogrammed. Let's make it 1011, and then it's 16 megahertz. Now, if we play, we'll be able to see it is printing hello from NC, right? It will automatically open. If in your case it's not open automatically, you need to right tap on this and then click virtual terminal. You need to right tap on this in a play mode, okay? In animating mode, right tap, and the last option is virtual terminal. So we can see this data, right? So that is the example of serial communication transmitting, right? Let me share it. Right. Now, let's come back to this. So here we already understood about the serial communication. Now we are going to discuss about another part. So I'm making it what? I'll change this line to loop. Okay. And then we will export it again. So once we export, what we are doing, we want to print in a loop. That means for infinity period of time, it has to print the same message, hello from Encino, hello from Encino. So simply, let's stop the circuit and play. So we can say it's continuously printing hello from hello from Encino, and doing it very fastly and doing it always in the same line. If you don't want it to print fastly, let's add a delay. Let's say delay of 1000, right? Also, if you don't want it to print in the same line always, simply say ln here. Ln means skip to new line. So it will print the same value, hello from Encino, after every 1 second, but in a new line. So let's see how it's working now. So if we play, now it's printing hello from Encino in a new line and with a delay of 1 second. If you say we have to print, suppose hello from Encino, in the next line we have to print serial dot print ln, and here we said how are you all, and then again a delay of 1 second. So now it will print two lines continuously for infinity period of time with a delay of 1 second each. 1000 millisecond mean 1 second each. So let's check the output of this. Yeah, correctly it's working, right? So now if you have any questions, please ask. Okay. How to identify the pin of the IC in practically? Practically, you need to check the pin diagram of your IC, obviously. For example, if suppose you are going for this at Mega 328, so you need to go at Mega 328P pin diagram. You search like this and you will get a pin diagram. Okay, so you have your IC. So in your IC, there is a half moon shape on the right, on the top. Yeah. So in your IC, you have the half moon shape here, okay, and it's defining this from the number actually, that it's pin number one. And if you start writing pin number one, two, three, four, five, six, this way, and then from here, see on the it's 28 pin IC. So 14 pins on the left side, 14 pins on the right side, top to bottom, 1 to 14, and right side, bottom to top, 15 to 28. Then this way you can identify which pin is PD0, which pin is PD1, which pin is PD2. You need to understand the concept of PD0, PD1, PC0, P1 when you are programming it using the Arduino IDE, because you are actually programming the IC but considering the pin numbers of Arduino board, right? So you need to remember PD0, PD1. That's how you can do. So if you see PD0 and PD1 is here, receive and transmit, correct? Then pin number 2, 3, 4 are here. I guess it's clear now. Now, next question is, I guess in every IC there is a C mark. Please place the C mark in your LHS, and just below the C mark, first pin is 0 and second pin is 1. So on. Good. I have a question that if I transmitting data in the baud rate of 9600 or 9.6 kbps, what will happen if I transmit data above 96 baud rate? It will give us any problem or not? Yes, obviously it will give you problem. See, if you transmit the data at 19.6 kbps and your program is able to understand that data in 9.6 only, it will like something, but how to explain you this? Suppose you are transmitting the data at 19.6 very fast speed, and your controller is set to receive the data at 9.6. That means controller is receiving the data at low speed, but you are transmitting the data at high speed. So at the receive pin, there would be a queue of multiple datas, right? And it will read slowly. So in between, your data may get lost or it may decrypt in any other form. Suppose you are transmitting hello, but because of the waiting of the data in a queue, it may become HELLO, may become HELO, or it may become HE only. So that depends how long is the queue. So always you have to match the baud rate. If you're transmitting 9.6, write 9.6. If you're transmitting 19.6, write 19.6. Ahmad Manzoor, there is no recording access for the day, and please ensure free certification. Sorry, that is not possible. Training is free, right? So, but certification is not. Fine. Now we are done with this. Okay. So same like yesterday. Today also we have the assessment test for summer training program, and it's around 7 to 7:15. So let's have a short break today also till 7:20, and then we will continue it afterwards. And from 7:20 we'll continue it till 9 or maybe 9:30. That depends upon the content which we have to cover, right? And once we cover that content, then we'll be discussing about the further facts of the ROS as well, which we have discussed yesterday. So now let's have a small break till 7:20. Meanwhile, you do your practice. Those who are not the participants of those exam, they can do their practice. I have already shared the codes and everything, right? So see you soon. See you soon after a short break. Hello everyone. I hope you guys are here. Let's start the session again. Please react if you are available, if you can hear me. Okay, fine. Very nice. Yeah, so before moving to the break, we were doing what? Let me share my screen again. Yes, so this was the last program we just created. Let me join from the other device. Okay, so what we have done in the last session was the serial communication part. And in this serial communication, we already understood how to transmit the data from the IC and to the terminal, right? Now, let's do the opposite part. This time, we will make it a bit different. This time, what we will do, we will transmit the data from terminal and your IC is going to receive the data. This time, we'll transmit the data from this terminal and IC has to receive. So obviously, what's the next step we are going to do is that this IC has to transfer the data. That means we have to use the transmit pin, correct? And when this IC has to receive the data, which means we have to use the receive pin here. But the point is that if suppose we transmit the data using this, for example, if I'm doing it, let's wait. First, let me save this because I guess we have not saved this one. It was P6. Yeah. So now I'm using the transmit pin and on this side I'm using the receive pin, right? Now, for example, if we write the data here manually, we'll type the data and this IC will receive the data. Fine, using serial.read command. Earlier we have used serial.print because controller was transmitting. Now we have to use serial.read because controller is receiving the data. But now my point is, suppose if we write the data here manually, it is transmitting, controller is receiving, and it will receive, correct? But how to identify whether it received the data or not? So for that, what we will do, whatever data we will be typing manually from this Bluetooth or terminal, this IC will receive and will ask this IC to reprint the same data, to reprint the same data, correct? So how we will do that? Let's use another terminal, mirror it, and here we will say transmit and it will receive. We can do in the same terminal also, but we may get confused that how if we are writing or controller is writing. So now what I'm saying that this one is the transmitting terminal where we will write. So let's make it the name, edit properties, and let's say TX. And here also edit properties RX. So now there won't be any confusion because it will transmit the data. IC has to receive, and once the IC receive the data, it will do what? It will transmit back to the other terminal because the transmit pin is engaged with the other terminal, and we can see the output here. Correct? If we do using only one terminal, we may get confused whether we write the data or controller write the data. So that's why we are using two different terminals for now. Now let's come to the coding. So this time we have to receive first. Okay. So for receiving the data, the command is serial.read. And then, as I mentioned earlier, whenever we have to receive the data, the very first command is if serial dot available is greater than null. If it is greater than null, then read the data. Correct? And whatever we read, let's store it in a variable. Let's say V. V is a variable. Now, what I mentioned that whenever we use the serial communication like GSM, GPS, Bluetooth, Wi-Fi, whatever data you are transmitting is always in the form of character. So let's define the type of this V as char. So like the data type integer, here we have a data type char. Correct? Now, char V is equals to serial dot read, and as mentioned, whatever we will read, we will transmit it back to another terminal. So I said serial dot print, and what to print? V. This time, don't put double quotes in this V. If you put double quotes, which means it will print only V. But actually, we don't have to print V. We have to print whatever data we are receiving in variable V, right? So it is already predefined as a data type char, so it won't give us any compilation error. That's why we are writing it as it is. Okay. Now let's export and let's come back to your design screen, your circuit screen, where we have done the circuitry part, and let's play it. So now we have two different terminals. The one is transmitting one. It is mentioned here, transmit. It is the receiving one, correct? So if I write A here, I'm writing here at this terminal, correct? And S and D and F and G, H, I, if I'm clearing, it's cleared, right? So whatever I'm typing in the transmitting terminal, it is going to IC. IC is transmitting back, and we can see that data in the receiving terminal. But whatever we are typing in transmitting terminal is not visible. So how to make it visible? Right tap on this. Here we have an option of echo typed characters. So if we enable this and write 1, 2, 3, it's printing. If we write Encino, Robotics, International session. So it's working absolutely fine, right? So now we are done with this part. Now we can simply move to the next part, which we have to discuss, that is wireless robot. But before that, let me first share the program. Done. Now let's go back to this and stop the circuit. Do you have any questions in this topic? Otherwise, we'll move to the next one. Okay, that's great. So let's switch to the next one. I'll open a new design now. Not new design. Let's open the previous design, that was P5, I guess. Yes, this robot. So this robot we made was a RC car, remote controlled car, and now we'll make it a wireless. And once we are done with this, then we will test this in the hardware also. Okay, just after this, we will be testing it in the hardware also. So what we have done for now is a RC car, and now we have to include the wireless part. So let's remove all these buttons for now. So I'll remove the buttons. So I'll rename this with a new design and saying it P7 design. And now let's delete all the part of buttons. Now let's include one virtual terminal, and it will transmit. Controller has to receive. We will transmit FLRBS to move this robot forward, backward, left, right. Okay. Earlier we were doing the same, but using buttons. Now we will do it with the wireless activity. Let's say Bluetooth or Wi-Fi. Okay. Now coding. So let's open the same program which we have done earlier, P5, and let me save it with a new name, P7. So in this program, there were buttons, but now buttons are not required. So let's delete these 4 lines. Let's delete the pin modes for those buttons, and let's write serial dot begin, because now we are doing the part of serial communication. Okay. And then here we are not required to read the data from buttons, because button does not exist now. So let's delete that part also. We have to use if serial dot available is greater than null. then read the data. So I'm saying v equals to serial dot read. And then here we'll say char v. Okay. So we have started the bracket here, read the data, comparing the values of those. And at last, let's put this end bracket, close bracket of curly bracket, right? So it's closing this loop if serial dot available, right? So now we need to change the condition. For forward, we will type F from the keyboard. So let's say if V equals to F, right? And for backward, it is B. So we'll say FB equals to B. For leftward, it is L. So let's say L. For right, it is R. And for S, we are making this condition for stop also. B equals to S. Correct? Code is completed. We haven't done too many things in this code because when we are already understood about the operations with the button and the serial communication as well. So now we have mixed up the concept of serial communication with the earlier made robot of buttons, right? We just replace the buttons with the serial communication. So remove all the pins of button, remove the pin modes of the button, remove the case where we were reading the data, and change the conditions that now we will receive the data from serial communication, and it may be FLRBS, whatever you type from the keyboard to control your robot in different directions. So now if I compile this code, it will give you errors, compilation errors actually. And why? Because what we are writing here is v equals to f, and f is not predefined here, correct? And actually we cannot predefine the value f because f we are going to receive from third party. F is not any pin, correct? We have not defined any pin for the forward operation or the backward operation. Those are the motor pins which are earlier defined, right? And V is defined because that data we are receiving in serial and storing it in a variable called character. So we cannot define this F, and it is asking to define F. Now we are in a difficult situation because code is giving the error. F was not declared. So, when we are receiving the data from third party or from Bluetooth or from any terminal, that data is in the form of character. And when we have to compare the characters, don't write this way. We have to write in this way. Characters are always enclosed by single quotes. So this was the mistake which we have done. Now we have to do the same for all. B equals to B as a character, L as a character, R as a character, and S also as a character. Now, if we compile the code, there won't be any errors. And now we can easily check the output also. And compiling, so let's switch it to the circuit part. And again, double tap on the IC to program it. We already have a program here, but we need to change this program from P5 to P7. So it's P7.eno.standard.hex. Let's assign the program and click play. Right now, I'll write here, and whatever we write, we want to see that. So I'm enabling this echo type characters. So I write F, it's moving forwards. If I write D, it's moving backward. If I write L, it's moving leftward. Only two motors are working at this time. And if I write R, it's rightward. And if I write S, it's completely stopped. Right. So how this program is working just by sending the wireless data, right? Using the Bluetooth or the Wi-Fi, correct? Also, if you want to print, suppose if your robot is moving forward and you want to check in the monitor also, you want to display that it's moving forward. So what we can do for that, we are going to use one other terminal. Let's use one other terminal and receive, and it will transmit. Got it? So now this one is the transmitting terminal. So let me mention it as a TX. This one is the receiving, so RX. Fine. Now, what we are doing that we will write F when it is moving forward, it has to print moving forward. Okay. So let's come to the coding part. It's not too difficult. What exactly we have to do when we receive the data, when we already compared the data, when it is moving forward using these four commands 1010, at the same time, let's write serial dot print. And what to print? Moving forward. And close this moving forward with double quotes. Also, try to print every time in a new line. Also, take a small delay so that we can see what actually it's printing. Okay, it's that this we are doing just to check, cross check. Okay, otherwise this delay should not be there. Why I'm telling you? Because when you type F, right, it was moving forward continuously, but in between, if you ask it to go backward, so it will take 500 milliseconds to jump to backward because you mentioned the delay. So once it complete that delay part, then only it will check the next condition that now you said to go backward. So it has to go backward. But in between, there was a delay of 500 milliseconds. And 500 milliseconds is too much for the robots when you are running it on a real time. Suppose your robot is moving in a scenario where it is defensing, okay, and there is a fire there and you asking it to come backward, but within 500 seconds when you ask it to go backward, but there was a delay of 500 milliseconds, so it may get fire. So that's why we have to remove this delay in real time applications. For now, when we are doing it just to understand what it is printing, how it is working, that time we can do it, then there is no problem. So I'm now pasting the same but changing it, moving backward, moving leftward, moving rightward, and not moving. Now let's export and come to this screen. Click play. So now we have two different terminals. This is the output terminal and this is the input terminal. So I'm writing here F, robot moving forward, it's printing moving forward. Now I set L, moving leftward, only two motors are working. R, moving rightward, only two motors are working. And B, all four motors are working anti-clockwise direction, backward motoring. S not moving. So it's now printing the exact data with all the values, right? So now we have done the part of wireless robot, whether you connect it with the Bluetooth or a Wi-Fi. So I'm sharing the code and then we'll jump to the next topic. It's fine. So now is the time when we have to discuss about the hardware also. Okay. So just give me a moment because now I'll switch the camera. Yes, so here we have this robot like yesterday, correct? And we already know about this because we have discussed it yesterday. These two for left side, these two for right side, and this one is the forward side, this one is the backward side. I mean the front side and the rear side. Okay. Now we have to move this robot using the wireless. So first I'm connecting the battery here. Here is the battery pack. So I'm connecting the battery here. Now, I already have the program, same program on this, right? How to upload the program, that process also I'll tell you. But first, let's check this robot, how it's working. So for that, I'm coming to mobile phone. Okay, I'll use one mobile phone to operate this using a Bluetooth. I'll operate this. So let me open the Bluetooth and then I'm turning on one mobile application, this application, right? So to go forward, backward, left, right. And now I need to connect this Bluetooth with the phone's Bluetooth with the robot's Bluetooth. Here we have a Bluetooth module. It's here. It is called HC05, the blinking one, right? So this one is the Bluetooth module we already have here. Okay. I'm putting this robot on the box so that when it moves, it don't go anywhere. Okay. And now I'm connecting the Bluetooth with my mobile phone. It's paired. I'll ask to go forward, to go stop, to backward, left, right. This way we have to check it, right? One second. Okay, it's done. Let me go there. Yes, now we'll connect it. It's not moving. Maybe something is wrong. We need to code it. Okay, let's upload the code. So I'm connecting the cable with my PC. Now, as we are doing the coding part, uploading part, so we also need to understand how to upload the codes. So once we connect the cable, as I have done for now, so first we need to check at which port the cable is connected. We also need the drivers to install to get the cable. When generally when you install this uh, Arduino software, that time it already installed the USB drivers for this. But if it is not installing, the package which I have shared, it already has the drivers for this board. So you can install manually from there also, right? So now you can see that the board is detected. How? I just do what? You need to search device manager. So when we search device manager, there we have the options of ports, right? And in the ports, we have the option of USB serial device, COM number 12. So that means this cable is connected with COM port number 12. Also, we can check it once more. If I remove the cable, look at the screen. When I remove the cable, the COM port 12 is no longer available now. Now I again connect this cable, right? I again connected the cable, and now we can see that it is detecting COM port number 12, right? Now, so we already have this code, and according to the this controller, the code is at any, I mean, the code is at pin number 13, 12, 11, 10, but the pins which are connected here is pin number 12, 11, 10, and 9, right? So we need to change the code here also. And one other part, according to the hardware, Bluetooth is actually not connected to pin number 0 and 1. So we need to change that part also. So for that, what I will do, I have another PC with me and I'll upload the code from there. But I'm telling you in this PC also how to upload the code. But this code won't work because the connections are something different and also Bluetooth pins are not 0, 1. Currently, we are not writing the Bluetooth pins. We are simply writing serial.begin because if we write serial.begin, that means the pin number 0 and 1 is set to serial, receive and transmit. But if you want to set any other pins, we need to write the header file for that. Or let's do one thing. We will change the code quickly here, here only. This would give you the exact clarification how it works with the hardware also, right? So let's do this. We'll code from this PC only. Just we need to switch the coding. So it's 12th pin, as I said, is 11th pin. This I am doing according to my hardware now. 10th pin and 9th pin. Okay. Other than that, I am not connecting this Bluetooth with pin number 0 and 1. Right. This is connected with pin number, let me check. This is pin number 5, pin 6. So I'm writing one header file here, hash include. See, if you don't want to write the header file which I'm writing, then default pins are 0, 1. But if you don't want to use pin number 0, 1, then you can include any other pins also. And how to include them is the method which I'm writing here right now. So hash include software serial.h. After this, software serial. Now let's define one variable, say Bluetooth, and pin number 5 and 6 we have defined. So now we have defined that Bluetooth is connected at pin number 5 and 6, and we are making the serial port using the software. Software means using the programming, because hardware already knows that the serial port is 01, but we are changing that. Correct? Serial dot begin we are using to print the data, but for Bluetooth we need to say BT dot begin and the same baud rate as 9600. Correct? Now, earlier we were receiving the data from pin number 01, but now we are receiving the data from Bluetooth. So we need to say BT dot available and BT dot read. That's it we have to do. Okay. One more and small change, because the application which I am using here will transmit the data capital F, capital L, capital B, capital R, right? So if I compare small f, it won't work. Let me show you what actually I'm saying. Let's first upload the code using the small letters only, small f, small b, and let's see what is actually happening. So what we have done, we set the board at Uno and port com number 12, which we already checked from the device manager in port categories, right? Now simply click on this option. You don't have to go to export, because now you are not running this on simulation. So hex file is not required for simulation part. It will upload the code, and once you click on upload, it will obviously do the same part. It will compile the sketch and upload to your hardware in the hex form using the cable which I have connected here, right? So now you can see the message done uploading, which means code is uploaded. From here, I can see, because we have mentioned serial.print moving forward. We have mentioned, let's write one more line here, serial.print ln value of b. Whatever we will transmit from this phone, whatever we will transmit from this phone, it will reprint on serial, and serial we can see from here in serial monitor, right? Serial monitor is actually what, whenever your code is not behaving well or your hardware is not behaving well, that time we can do what? We can take the help of serial monitor. It is very important when we debug the codes. Debugging means identifying the errors, troubleshooting your code. So if you start using serial monitor to debug the code, this would give you the clarification exactly what's happening with your code. For example, suppose you are transmitting the data from your mobile application, and that is working absolutely fine, but still you are not getting any output. So there may be a reason that either your hardware connections are wrong, or maybe your phone is transmitting something else, or maybe you have not defined the baud rate in a right way. So that's why we are taking a help of serial monitor. It will print the exact value, whatever you read from the mobile phone. Okay. And then further you can check if you receive the correct F and this condition is satisfied, and it is also printing moving forward, then and still it's not going in forward direction. That means now there is something wrong with the hardware. I hope you got it. What I said, if you receive B in the form of forward, which is F, if this condition is also true, it is also printing moving forward in serial monitor. That means everything is working nicely in your coding, but there is something wrong with the hardware, because you already said 1010 is the command to go forward, but still it's not going forward. So maybe your battery is damaged, maybe your connections are wrong, maybe your IC is not working well. So that means something wrong in the hardware. So that's why we use this serial monitor. So as I have changed a few part in the code for now, which was serial.print. So let me upload the code again. We need to upload the code again. Once we upload, we'll come back to the hardware screen. Yes, code uploaded. Let me go back to this. Let's open serial monitor also in the full screen mode, and let's come here. Okay. Now what I'll do, I'll try to send the data from this uh, mobile application, and then we will check what actually happening here. Okay. So let me remove, let's not remove the cable, because you want to monitor the data on serial monitor. Just give me a moment. Now I'll reconnect the Bluetooth. Yeah, so the problem is that Bluetooth is not connecting here. That's the reason it was not working earlier. Now it is blinking. So now let's try to connect. Bluetooth connected. I'm sending the command for the forward, right? I sent the command successfully. What we have on the simulation, sorry, not simulation, on the serial monitor is nothing, right? If I send B, it's nothing. L, it's nothing. S is nothing. R is nothing. Nothing we are getting onto serial monitor. That means something is wrong from the coding side. So let's go back to check the coding. What we have said is Bluetooth dot available is greater than null, pt dot read and store in V and then serial dot print V. It's absolutely fine. There is no problem here. Then serial dot begin, bt dot begin and pin number 5 and 6 is also correct, right? Software serial dot h is also correct and bt dot begin is also correct. Fine. Let me do it again. Not printing anything. Okay, fine. No problem. We'll change this 6 and 5. Uploading the fresh code. Okay, now let's see. So the problem is actually not the codings. Code was fine. Code was not wrong because now it's not blinking the LED for transmit or receive. So this may happen, when we work with the simulation, everything goes smoothly. But when we switch to the hardware, this may happen sometimes that you may face difficulties receiving, transmitting, small wirings. This may happen. But no worries, we will resolve it definitely if we have the knowledge about that particular thing. See now, look at the serial monitor. It's printing F and S, but still this robot is not going forward, not going backward, not going leftward, not anywhere, right? Why? Because as I mentioned, see when I'm transmitting the data, it's printing it in a capital. And what we are comparing in a program is in the small letters, right? So now the last part we need to resolve is writing capital F, capital B. Be ready with your questions if you have. After this, we'll handle the questions and then we'll jump to the next one. Capital R and capital S. Now let's upload the code. Again, I'm uploading the fresh code because we have seen that the data was in capital letters and we were comparing it in a small. We have done this, code is uploaded, right? So once your code is uploaded, let's come back to this serial monitor, right? And now I'll do it again. So now you can see the bot is moving forward direction, correct? I'll say B. So now it starts moving backward. If I say left, so now only two motors are working and those are right side motors. These two motors are not working. Correct. Now, if I say right, so now these two motors are working. Correct. But these two motors are not working. So it's going right direction. Left motors are working. And if I say stop, it's not working anymore. Right. So now if you have any questions, ask and then we will jump to the next one. Sophia, the text test is already completed. It was yesterday and today. For next test, please follow the LinkedIn channel of Encino Research and Development. James, I guess we have connected the real IC to laptop, right? And we have programmed it. Ronak, which code exactly you want to understand? which part of the code, because we have completed the motors part, then we individually completed the serial communication part, and now we have merged both the codes. So exact path which exact part of the code you want to know? You can also unmute yourself, there is no problem. Ronak, do you have any questions, or you want to understand the whole code? Serial communication. Bhupender, in my case, this motor driver is overheat every time. Why? Because you are using L29 3D and I'm using L29 A10. That's what the difference. I mentioned this yesterday also. You must use L29 A10 because L29 A10 has the power to cater the high amount of current also. In your case, you are using L29 A10 only. Still, it's happening. So maybe you are connecting it in a wrong way, right? If you see, I have connected how I'm writing in a program. Nothing else I have done. The battery is 12 volt, connect directly to L29 A10 and the V input of your board. Correct? As I mentioned yesterday, in your IC, if you are using the IC, then you can give only 5 volts. But if you are using the Uno board, then you can directly give the 12 volts. So the positive of your battery, you need to connect with the 12 volt pin of L29 and with the V input pin of board. And the negative of battery, you need to connect with the ground of your board and the ground of your L29A10. Then your L29A10 also need 5 volts. It has one more pin of 5 volt. But there is no option for the 5 volt because your battery was 12 volt, right? So what you can do now, when you provide 12 volt to your board, it converts that 12 volt into 5 volts also. And you can receive that 5 volt from the pin that is called 5 volt itself. So there is a pin of 5 volt in your board. So connect that 5 volt pin to L29A10. That's it. Now short your two left side motors and right side motor, how we done in the simulation also. Same you had to do, and I guess after this you won't face that problem. And try to purchase the good IC L29A10. Maybe if you are purchasing it online from any trustable source, so purchase it from a trustable source where you can get it a good quality. Okay, James, a good question. See, when we talk about the IC, currently I have connected the USB cable to this board and it was Uno board, right? When we program the IC individually, first of all, you need a programmer. Okay, you can't directly connect the IC with this USB. You have two options. Either you need a programmer. Okay, programmer is a device which you can use to program the uh, IC. Okay. And if you don't want to use the programmer, then the second option is that you create your own USB connections. And for that, you need to use 6 pins of your IC. Those are MOSI, MISO, SCK, VCC, reset, and ground. These are in serial order. MOSI, master output slave input. MISO, master input, slave output, and SCK or clock reset to reset your controller, and VCC and ground is for 5 volts and ground. Okay, this is the second option. You have to use the 6 pins and connect with the USB. You need to create the circuit. So better you use the programmer. And one more option you have. Because you know this Uno board which I have is a dip board. Dip board where you can remove the IC. Let me show you. I have another board also. See, this is called dip board. So you can remove this IC. Okay. And because you don't want to use the whole board, so remove this IC, connect the IC which you want to program. It should be same at Mega 328P. Connect the same IC here. Use this USB cable and program it simply. Correct. Now, Let's come back to the Ronak. Uh, Prem, I guess I have done this same right now. For the real world, I told the solutions. I'm coming to the program to make it clear, right? These are the pins we have used for motors, MLP, MLN, MRP, MRN. And for software serial, we have introduced two new pins, 5 and 6, because I'm not using 0, 1. There is one more reason why I'm not using 0, 1, right? Because when you connect 0, 1, suppose your pin number 0 and 1 are engaged with the Bluetooth device, right? And you are uploading the code. So actually, pin number 0 and 1 is to receive and transmit the data, right? So if you connect your Bluetooth at pin number 0 and 1, and you are trying to upload the code to your board, but actually your pin number 0 and 1 are engaged with the Bluetooth. So your board understand what? That it has to, because pin number 0 and 1 are engaged, so it understand that it has to transfer the code to the Bluetooth module, right? What is the flow of the data? You are transmitting the code from your PC to your Uno board using the cable. But actually you have engaged pin number 0 and 1 of your board. So board understand this Bluetooth device as a programmable device, and it transmit the program to that Bluetooth. And actually Bluetooth is not a programmable device. So that time you face the error uploading the code. So every time you connect the 0, 1 while uploading, you need to remove those pins. Those pins should be free while uploading the code. And why your board understand this? Because you know there are few boards like Mini, Pro Mini. They don't have any USB ports to program it. So whenever we have to program the Arduino Mini board, we need Uno board as well. So what exactly we do? We connect the receive and transmit pin of the Mini board to the transmit and receive pin of Uno board. I repeat, we connect the receive and transmit pin of Mini board to the transmit and receive pin of Uno board. And then here we set tools, board, and Mini, right? And then we click upload. So the code, what is the flow of the data now? From your PC to Uno to Mini. So that time your Uno board understand that it has to transfer the code from Uno itself to Mini board because the number 0 and 1 are engaged. And that time because Mini is a programmable device, so it upload the code easily. There you won't face any error. But here we have one more condition. In your board, when you are connecting it to program the Mini, you need to remove this IC. This is a dip board, so you can easily remove this IC from the base, right? If you purchase the SMD board, you cannot remove the IC. That is actually somewhere around 400 to 500 rupees. But in that case, you cannot remove the IC. So always purchase the dip board for better quality and reliability. Correct? Now, come back to the coding again. So what we have done here, we have used pin number 5 and 6 because every time removing the pins from 0, 1 is quite difficult task, right? So we are using other pins, pin number 5 and 6. So what we have done is that defined Bluetooth receive pin as 5 and 6 pin is transmit. Then we defined all the pins as output, started the serial communication at 9.6 kbps, started the Bluetooth communication at 9.6 kbps. Now, why we are defining both? Because we have to print the data on serial monitor as well as on the Bluetooth. So that's why we are initializing both, right? If you don't initialize this, you cannot see any data printed like this, right? This we use for debugging, as I mentioned earlier. Now in the loop, what we said, if the data is available at the Bluetooth port is pin number 5 and 6 and receive pin is pin number 5. So if any data is available at pin number 5, read that data and store that data to B. B is always in the form of character, so compare that as a character. Now whatever you read in B, print that. And now it's very simple. Compare if B is equals to F, go forward. This code is the same code as earlier, as yesterday. Also print moving forward. Then if it is B, then it is backward and print moving backward and so on till last, right? So this is the flow of the code, what we have done. So I guess now we are done with this scenario and we should start a few part of analog also where we can change the speed of the motor. Currently, what we have done is only turning on the motor and turning off the motor. But for the real world scenario, it's not only linear motion. Somewhere we need the angular motion as well. Somewhere we need to change the speed also. Right. So now we are jumping to the next topic, and we will come back to the robot again. But for that, first we need to understand how this analog works. Right. So the next topic is analog communication. As I mentioned earlier yesterday, that we have few pins, pin number 3, 5, 6, 9, 10, and 11. These we use for analog write. Okay, and analog write is not 0 or 1, it is 0 to 5 volt. Earlier, when we used digital, it was 0, 1, which means 0 volts or 5 volts. But when we are talking about analog mean it may be any voltage between 0 volt to 5 volts. But the problem is, you know what? Your controller pins does not understand the voltage. They only understand the logics. And unfortunately, we have only two logics. The first is 0 and the second is 1, where 0 is 0 volt and 1 is 5 volt. But when we are talking about writing all the values from 0 volt to 5 volt, and if we write it like this, suppose digital write was simple, digital write variable, comma, 1 or 0. But in analog, how to write? If we write analog, write variable, comma, zero point 0.7 volt. So it won't understand what exactly you want to say. In, in your language, it is a voltage, zero point 0.7 volt, but it does not understand the voltage, right? And only two logics we have 0, 1. But for this range of 0 to 5 volt, what exactly we can write? That is called the resolution. So the resolution of these analog pins are 8 bit. Okay, it is 8 bit. And if we calculate the 8 bit, it is 2 to the power 8 equals to 256, which has a range of 0 to 255. Try to understand this because it is very important topic, right? What I said, we cannot directly write the voltage. It is wrong. Okay. So resolution is 8 bit for these pins, pin number 3, 5, 6, 9, 10, 11. It is 8 bit resolution. And 2 to the power 8 is 256, which has a range of 0 to 255, which means we can write these values to explain the voltage of 0 to 5 volt. How? Let me explain. If we write 0 value, that means we are writing 0 volt. And if we write 255, that means we are writing 5 volts. Okay. If we write 0, that means we are writing 0 volts. And if we write 255, that means we are writing 5 volts. Now, let's calculate the other values in between. For example, if I just have this 255, so this means we are writing 2.5 volts. If we say 64, so that means now we are writing 1.25 volts. Correct? Now, if we calculate it for 1 simply, so it is 5 divided by 255 volts. And for 20, suppose it is what? 5 divided by 255, which is to be multiplied by 20. Simple mathematics I have used here. Okay. For 0, it is 0 volts. And for 255, if it is 5 volts, then for 1, it is obviously 5 divided by 255. Now you can calculate it for any random value. For 20, it is 5 divided by 255 multiplied by 20 volts. Correct. So this amount of voltage you are writing to your pin using the data from 0 to 255. So what you can write in the analog write command, it is analog write variable, comma, 0 to 255. It may be any voltage. Okay, you have to write only one number here. Got it? So let's check how this work when we connect any motor with analog command. Okay, for that I'll create a new circuit. So let's pick at Mega 328P and a crystal. Okay, I need to switch my camera back to my face. One sec. Yeah. So coming back to the circuit, right? Crystal we have done, capacitor, and one motor I'm using, this motor. Okay. And then let's connect it here at Mega 328. Again, the crystal for clock frequency. Connect it at pin number 9, pin number 10, external crystal oscillator pins. At 180-degree, we need to rotate this also. Now, this one is positive terminal. So let's connect here. Let's connect here. These are negative terminals. Let's connect those terminals with the ground. Let's change the value to 22 picofarad. Also this value. Now we have one motor. Now we cannot directly connect the motor with your IC. So we need to use one L29 also. So let's pick one motor driver, L29 3D. If suppose your motor is 12 volt, obviously your pins cannot provide 12 volts. So we are using motor driver. But if I say that we have 5 volts of motor, then can we connect directly with the IC? Answer in the chat box. Okay, then we'll discuss it later. I ask a question, you need to answer that in the chat box. And the question is, if suppose we connect 5 volts of motor with the IC, can we directly connect with it? Do we need this L29 in between in that case? For now, I'm considering the example of 12 volts. That's why I'm using L29A10. Okay. Or L29 3D. So output 1 and output 2, I'm engaging it. This is pin 12 volts of supply. And this one is ground. This we have discussed yesterday. So doing the same. So now we have to use two pins for the motor. So I'll be using pin number 3, 5, 6, 9, 10, 11. Any pins out of those. Okay. So if we start counting from here, this is pin number 0, 1, 2, 3, 4, 5, 6, 7. And here we have PB0, PB1, PB2, PB3, PB4, PB5, PB6, PB7. So which pin is actually pin number 13th? Which pin is 11th? We need to check. So let's come back to this UNO board, right? So that is a UNO board. It is PB5 is 13th pin. That means from here, from PB0, you have 8th pin, 9th, 10th, 11th. And now we have to use two pins, which must be analog pins. So I'm using pin number out of these, right? So for example, if I use pin number 10 and 11, so which one is 10? This was 8, right? Yeah. So this was 8. This one is 9th. This one is 10th. So let's use 10th pin and 11th pin. So 10th is positive. Do remember, 10th is the positive of motor and 11th is the negative of the motor. Now let's come to the coding part. So let's write int motor positive is 10th and motor negative is 11th. Same pin mode. MP comma output. Obviously, it's actuator. So we need to define the pins as output. Copy and paste. And the next pin is also output. That is MN pin. Right now, first case I will write the full speed. Second case, I'll write the half speed. Okay. First, I'm doing the full speed. Full speed means 5 volts, and 5 volts mean 255. Right? Full voltage, 5 volts, 255. So how to write? Analog, write, and let's say MP comma 255 and analog, write MN comma 0. Positive pen is 5 volt, negative pen is 0, so that we can see the motor is working at full speed. Okay. You can connect the ground also to negative pin of motor. Don't use the pin number 11, not 11, yes, 11. If you don't have to rotate the motor in anti-clockwise direction. If you want always in a single direction, directly connect the ground. Okay. So let's say it's P8. We will do too many things, but quickly we will do it. I've compiled and exported the code coming here. Let's save this design. P9. I guess it's P9 design or what? P8. Okay. So design is P8 design. Fine. Let's double tap to upload the code. P8 settings and 16 megahertz. Now let's go play. So now we can see the motor is working at the full speed. I do understand this would be difficult for you to uh, check the full speed at this simulation, but I'll show you this example in the hardware also. Wait for this, right? Now, after this, what we are saying that we have to rotate this in at half speed. So I'm saying 128. Okay. Now upload the code and stop and replay. So now it's working at the half speed, right? So two different scenarios we have checked. Let's try to have this in the hardware also. Okay. So let's open this P7, which we have done earlier. We have connected 12th and 11th pin. 12th, I'm talking of these two pins are what analog pins. So let's focus on the right side motor. So right side motors we will be checking for now to work with the analog. Okay. So I'm making it. Sorry, 10 and 9. Okay. So I'm making it 10 and 9. And both pins are analog. At 10th pin, I'm writing half voltage. And at 11th pin, 9th pin, sorry, negative pin is 0. Okay. And let's upload the code. So to upload the code, also, we need to connect what? We need to connect the cable. Also, I'll switch my camera to the hardware. So these two motors we have to focus because right side motors we are programming. Okay. Now I'm coming back to the program and uploading this code just to check how right side motors are changing the speed. See, look at this. Very low speed is there, right? Both motors are working, right? Now I'm writing 255 and changing the code. So as soon as it transfers the code, you can observe the speed. Let's do one more thing. Okay. I'm removing the cable. We will write a code where we will observe that motor start increasing the speed slowly and then decreasing the speed slowly. Right. And how to do that? For that part, first let me remove the cable. Let's not waste the energy. Also, let's remove this battery source. Right. Now, what I said, let's start increasing the speed and decreasing the speed. Slowly we will do this. Okay. For that, what exactly we have to do for now? We need to understand because to increase the speed, we have to write all the values from 0 to 255 and then all the values from 255 to 0 to decrease. And to write all the values in the program is quite lengthy part because if we write mp comma 0 then delay, then mp comma 1 then delay, then mp comma 2 then delay, so that means almost 256 line of the codes to write all 256 values, and then for decreasing another 256 lines, and in between there is a delay, so that means another 256 lines of the code for increasing and another 256 lines of the code for decreasing. So this way the code is almost for 1024 lines. 256 plus 256 for delays, 256 plus 256 for writing the values from 0 to 255 and 255 to 0. So this will make our code very lengthy code, right? So what I will do for that, I will use a for loop. So let's now understand how for loop works. For loop is basically a finite loop, right? And finite mean maybe 5 times we have to run, maybe n times we have to run, right? So that is called the for loop. And how it works, let me write the syntax first. There are two type of syntax for the for. The very first is for int I equals to 0, I less than equals to n, and I plus plus. This means what we are saying, start the value of I from 0 and start increasing the value of I. Plus plus mean I is equals to 0, make it plus I is 1, make it plus I is 2, make it plus I is 3, and add plus 1, increment the value until we reach the n number. So for example, if you have to run this code for 5 times, you will say less than 5, right? So now this will run for 5 times, 0, 1, 2, 3, 4. Once the value of I is equals to 5, the condition is false. And once the condition is false, it will not increment your value. So that is the syntax. Okay. So that exact syntax is like this one. And here you can write the statement. So whatever is statement you are writing in a for loop will work for n times according to this loop. And if we have to write in a decrement order, you can say this time start from n. Increasing order was example, n is 5. So 1, 2, 3, 4, 5. Now decreasing order is 5, 4, 3, 2, 1. So now I'm starting from 5 mean n. So I is equals to n, and if I is greater than equals to 0, I minus minus. And whatever statement you have to run inside the loop, put that here. So this is the syntax of the for loop, right? Now come back to the coding. So now what I will say here, as we know, we have to write all the values from 0 to 255. So I'll say for int I is equals to 0, I less than equals to 250, less than 255, and I plus plus. And then do what? Do write these two commands here, but don't write 255 directly, say I. So what we are doing, initially the value of I is 0, so it will write 0. Then it will take a small delay of say 10 milliseconds or 2 milliseconds. And then it will check if the I 0 is less than 255, then increment the value. So now the value of I is 1. So now it will write one value here. Again, it will check the condition. If one is less than 255, then again increment I goes to 2. Then I goes to 3, I goes to 4, and till 255, it will increment all the values. Now we have to decrease the speed. So let's do the same, but this time we are doing the decreasing operation. That means start with 255 and greater than 0 and I minus minus. That's it, right? Now let's upload the code. Let's upload the code. So to check the output, again, we will switch to the hardware screen. Code is uploading. Okay, there is error in the code. Need to check what's the error. It's saying serial port can't open. Let me show you. What's saying? Serial port can't open device COM12 because I have removed the cable. So I need to connect the cable again. So I'm connecting it. Right? Connecting the battery again. Previous code is working for now, right? Because that was the previous code which we uploaded to work with the full speed or at the half speed. But now I am uploading the fresh code. It's uploaded. And now observe, slowly increasing the speed and then decreasing. Then again, slowly increasing the speed and decreasing. So that's what we have achieved now to control the speed as well, right? If you want to check this output, I can show this output in another setup of LED. Okay, so let's do what? Let's remove the hardware robot. I'll connect it again soon when we'll be discussing about the ROS part. So for now, I have removed this and connecting the LED here. I hope you can see this LED, right? The positive, this is a breadboard, and these are the jumper wires. So the positive of LED is white connector, and negative of LED is the brown connector. I'm connecting, and let's connect it to the board. Let me switch the camera. Yes, now it is clearly visible. So we have to connect the positive of LED with pin number 10. So pin number 10 is this white connector, and in this board here we have the pin number 10. So I connected it at pin number 10. And the brown is the negative one. So we need to connect that with the pin number 9. So I'm connecting with pin number 9. That's it. Now let's connect the cable. As we have changed the board, so we need to check the port. And that we can check in this device manager. It's COM18 now, right? So let's go to tools and ports. Now we need to switch it to COM18 and let's upload the code. Now same output we can observe with the intensity of the LED. Earlier it was speed of motor, now it is intensity of LED. I am doing it without any resistor because my LED is 5 volts. Now you can see slowly increasing and slowly decreasing. This is called fading of LED. This is called fading of LED. Earlier, when we started the coding yesterday, we have done, let me open the code also, blinking part. Blinking was normally on off, on off, on off. I guess this is the blinking part. Pin number 13, high and low, right? I'll make it pin number 11th because 11th was no, not 11th, 10th because 10th was the positive one, right? And uploading the code. Now I'm uploading this code to check the blinking output, right? 10th is output, 10th is high, 1 second, 100 milliseconds, and 10th is low. But I have uploaded the code, you can see, but still it's not working because the negative pin of LED is now connected with pin number 9. That was the previous code here, pin number 9. But now we have changed this to nowheres. In this program, we have not defined pin number 9. So let's not use pin number 9 and I'm using the ground directly. So now I'm switching it to ground pin and we can see LED is blinking. So there is a difference between blinking and fading. So now, right now it's blinking. Earlier it was fading when we were writing the analog write. So I'm done with this part. We have controlled the robot using the buttons as well as the serial monitor, as well as the virtual terminal, as well as the mobile application. And that mobile application was this one, which is not actually available on the Play Store. This is my own application. But yes, you can check the related application in the Play Store as well. Right now, I'm coming to the question and answers. If you have any. I asked one question: can we connect the motor directly, 5 volts of the motor directly with the IC of the board? The answer is no. Can you please brief more why no? Why we cannot connect it? Is there anyone who can answer this? Why we cannot connect it? Because IC knows only 0 and 1. So what? IC knows 0, 1 and 0, 1 is 0 and 5 volts. So why we cannot connect? Because the motor is 5 volts. Vignesh said current ratings. Ronak said because it requires driver. The supply is not efficient. No. The answer we got from Vignesh is absolutely fine, right? Supply is not efficient. Can you please brief voltage or current you are talking about? See, the voltage is 5 volts and motor is also looking for 5 volts. So voltage is equal. What controller is giving, what motor is looking, both 5 volts, that means satisfied. So we can connect. But when we talk about the current, that time we have to think about because when we talk about the IC, this Atmega 328, the current drawn per pin is 10 to 20 milliamperes. 10 to 20 milliamperes. It may be 50 milliampere if the voltage is 3 volts. If the voltage is 5 volt, then the current is maximum 20 milliampere. And when we talk about a motor of 5 volts, generally it requires around 1 ampere to operate. Correct? And in total, your board has only 1 ampere. The total board capacity is 1 ampere. And your one pin can give up to 20 milliampere. But current does not depends upon the provider. Actually, it depends upon the consumer, the load. If motor you are connecting, which is having a voltage of 5 volts and requirement of the current is 1 volt to start with, so it will consume the total current 1 ampere. And we know that the board only has 1 ampere. It is not having sufficient amount of current to sustain. So in that case, when you connect the motor of 1 ampere with the IC directly, motor consumes the all current and your IC goes off. And if your IC goes off, automatically your motor is off. Once your motor is off, IC again get the current. When IC again has the current, then motor again consume the whole amount of the current. Again, IC goes off, motor goes off. And this operation repeat for n number of times. depending upon the reliability and the capability of your controller. Because this process is doing actually what? Consuming the current, turning it off, which means producing the abnormal process and which cause the heating of your IC. So if it reach the temperature which is not good for the IC, it may go burn. So that's the reason why we do not connect IC directly with the 5 volts of motor. Because it's not only about voltage, it's about current also. So the Vignesh was absolutely fine. Current ratings also we need to check, right? So now we are done with this. Now I'm removing this hardware, switching the camera to my face, and we are going for the next topic. So now we'll be discussing about the last for this robotics. After this, we will jump to ROS, Robot Operating System. Okay. So for that, we are considering one ultrasonic sensor, right? So first of all, I'm going to pick one ultrasonic sensor. Let's pick at Mega 328P, and then ultrasonic sensor, and then crystal oscillator, and then capacitor. So let's drop at Mega 328 here. Ultrasonic sensor I'm doing here at this point. Okay. This is simulation. Ultrasonic sensor we use to detect the distance and to identify the obstacle. Here we have two speaker kind of things looking like the eyes of the robot. And there we have two pins, trigger and echo, where trigger pin is responsible to transmit the sound wave, whereas echo pin is responsible to receive the sound waves in the form of echo. 5 volts we connect to power up this sensor. So let's connect 5 volts and let's connect the ground. And trigger and echo, we need to connect any of the pins with your board. So I'm connecting echo trigger with pin number 5 and echo with pin number 4. Okay, sorry, I connected wrongly. I'm saying trigger with pin number 5. So 5 is this one, PD5, and echo with pin number 4, which means PD4. Okay. Now ultrasonic do what? Basically, we know the speed of sound, standard speed of sound, right? And according to that, we calculate the distance. So whenever you place any object in front of the ultrasonic sensor, whatever sound wave you transmit, it come back in the form of echo. And you need to write a program which can actually calculate the time taken by the sound wave to come back. Suppose you transmitted the sound wave at 10th second and it received back at 11th second. That means total time taken is 1 second, and that we need to calculate using the program. Once we calculate the time, we can easily identify the distance because we already know the relation between the speed, time, and distance. Speed is standard for sound waves. Time we have calculated. So that's how we can calculate the distance in centimeters. Now, whatever distance we will get with the object, we will print that on a virtual terminal. So let's use one virtual terminal here. So this one is the receive pin and this one is the transmit pin. So whatever speed we detect, we will print that on this virtual terminal, right? And what else we need? That is obviously crystal and all. So let's connect the crystal on other side and the capacitor. Pin number 9, 10th, obviously. Okay. So doing these connections fastly because we know about these connections, and I'm connecting another ground, and also you can connect to the same ground because when we work with the hardware, there are not too many ground options available. So we use the common grounds everywhere. We are done with this. We are done with this, right? Now we need to write the code. But right now, we are working with the simulation. And how we will identify the exact distance for the obstacle. So for that, we have test pin here in this simulation diagram. When we work with the real-time scenario of this ultrasonic sensor, that time we do not have any pin for the testing. There we need to place the real object to identify the distance. But for now, we have option of test pin in the simulation. So at test pin, I am connecting one potentiometer. It is pot edgy. The keyword is pot edgy. Okay. There are three pins here. So this pin is the output pin of this potentiometer. This we need to connect with the 5-volt source, and this we need to connect with the ground. So what exactly this potentiometer will do? We have given the 5 volts. So if we move this upward, it will give around 5 volts, will increase the distance. That means the obstacle is going far away. And if we place it to the towards the 0 volt, that means the object is nearby. Okay. So now let's write the code for this. So this would be the new one for everyone, because ultrasonic sensor and even whatever sensor we have, they have their different physics, and we need to program them accordingly, right? So let me close all the codes first, and then we will be doing the fresh code for this ultrasonic sensor in a different style, but we have not done till now, right? So let's come back to the circuit for one sec. Here we have used trigger pin with pin number 5, do remember, and echo pin with pin number 4. Okay, let's write the code. So first I'm writing in a different style now. It is hash define. You can also use int. I am saying echo pin equals to, which was echo pin. Echo pin is pin number 4 and trigger pin is pin number 5. So let's write 4 and again hash define trigger pin equals to 5. Now in setup, because we have to print the value on virtual terminal, so let's say serial dot begin to print the distance 9600, and then pin mode, because echo pin is to receive and trigger pin is to transmit. So let's write trigger pin as output and echo pin as input. Then let's come to the main part of the code. So what exactly we have to do here? What I said, we will transmit one sound wave and then we'll receive it back. So whatever time taken from transmitting to receiving, we need to calculate. Okay. So what exactly we have to do? First, let's transmit one signal. And to make sure we are transmitting only one signal, what actually I'm doing now? Let's see. First, I'll say digital write trigger pin, comma low, and then delay of 2 milliseconds. Digital write trigger pin, comma high, and then again delay of 2 milliseconds, and then digital write trigger pin, comma low. So actually we have to transmit only one signal. But to make sure that it transmit one signal only, first we made that pin low and then transmitted the signal and then again make the pin low. That's it we have to do. Now we have transmitted. So obviously if there is an obstacle in front of the sensor, it will hit that obstacle and reflect back. And we need to calculate the time. For that, we have a predefined command called pulse input echo pin, comma high. So what we are saying, calculate the time of receiving the sound wave at the echo pin and store it in a variable, let's say duration. But duration is undefined till now. We have not defined this variable. So let's go here and write long data type and duration. Okay. And then, as I said, we know the standard speed of sound time we have calculated. So I applied the formula and calculated the distance. So the distance is equals to duration divided by 58.2. You can calculate this by yourself because you know, or you also know the speed of sound. And also do remember, here we are working in milliseconds, and the speed, the formula which I have applied is for centimeters, right? Now we have calculated the distance and store it in a variable distance. So obviously we need to define this distance also. So I said float because distance may be 1.2 centimeter, maybe 10.5 centimeter. So I'm saying it float. And also why float? Because we are dividing it with the decimal number also. Now let's print it simply. So serial dot print every time in a new line. And what to print? Distance. And then after 1 second, again check. So I'm not asking it to check continuously, check it after 1 second. But when we work with a robot, we need to check it continuously. So there should not be any delay at that time, right? So now let's save the code. Where is the folder? Here it is. P9. Export. And meanwhile, I'm saving the design also. It is done, right? So let's upload the code. Nothing is here. Okay. We not need to put equals to here because we are using define. If it is int, then we can put equals to. Now there is no error. Text code is generated. Click OK and click play. Okay. So now it is giving us one other error, that is unable to open hex file because this is not inbuilt in your Proteus. So I have included the hex file, sorry, the library files of the this sensor like we have done yesterday for the Arduino, right? So we need to map the hex file also. So hex file is in this folder, I guess we have. It's not here. Here we have the hex file. I'll share the library package of this ultrasonic sensor with you. You can import that and you have to copy those files to this location, which we did yesterday also. Program files, lab center, Proteus 7 and library. Paste those files here, ultrasonic sensor library, then you'll be able to import in your Proteus software. Now, if you click play, it's printing the distance. No, it's not printing. Nothing is on this screen. Written correctly. Transmit pin, receive pin, and here echo pin is pin number 5, and sorry, echo pin is pin number 4, and trigger pin is pin number 5. That's what we have written here, I guess. Echo is 4, trigger is 5. Okay, no problem. First, let's check the random data to print. Serial.print. Hello. First, we'll check what's happening. Then we'll come back to this debugging part. Okay, stop and replay. Is it printing hello? No. So that means the code is not even printing the setup part. So we cannot expect that it will work for the loop. Okay. Why it's not working? Because we have not set anything here. That is the role of the settings and the crystal oscillator and the frequency. See, now it started printing the values. Every 1 second, we are getting the new values. Okay. And if I change this test pin, it's changing the value as well. So in the real time, we can put the object to identify. The same code will work. You already know how to upload. Now you already know how to connect the ultrasonic sensor. This code will give you the exact output of ultrasonic sensor, right? So now we are done with this part also, correct? Now let's implement this ultrasonic sensor with the project which we have earlier done for the wireless robot. Okay, so I'll open that design now. Open design of, I guess it was P7, I guess. Let me check. File P7. Yes. So now we will implement the ultrasonic sensor in the same code. If we send the command forward and robot is going forward, but the distance is less than 20 centimeters, it should stop, right? So let's pick ultrasonic in this circuit now. And then, like earlier, 5 volts, ground, and how we connected the trigger pin. Let me check the code. Trigger pin with 5. Okay. So trigger pin with 5, this one, eco pin with the 4, like this. The same we have mentioned in the code. Okay. And test pin. For test pin, we need to put port HG. Let's connect this one here at test pin, this one at 5 volts, and this one at ground. Now let's open the code. P7. P7 was the code which we did for moving the robot in forward, backward, left directions, right? And what we have done with this code, when we say F, L, R, B, S, that time it should work, right? But if you remember, we made few changes in the code because we connected the Bluetooth at pin number 5 and 6. So I'll repair the code. Okay, let me paste it again. And now, as we know, we are not working with the hardware. So 01 we will be using. Let's remove the BT dot begin. Let's change it to serial dot available and serial dot read. That's it. Okay. And this time, do remember we have to type in capital so that it can work. Fine. Now, this was the code which we have done for moving the robot in different directions with wireless. But now is the code we have here is for ultrasonic, and we have implemented both on the backside, right? So first of all, let's save this design with the new name. Let's say P8, P10 design, and code. So we need to merge both the codes. This code is for ultrasonic. This code is for moving robot wirelessly. So first of all, how to merge two codes? Try to understand. This is the code. I'm not touching it, right? I'm not changing anything right now, but I have to mix this code. So this is the part of definition before setup. So let's copy and paste here. Then here we already have serial dot begin, so no need to pick it again. We need to define trigger and echo. So let's write here. Now, here we are receiving the data, and here we are doing the ultrasonic part. So first of all, let's copy the whole code of ultrasonic, copy and paste it here. Right? What we said, the whole code of ultrasonic we have here, it will print the distance, and then we have the code of serial port available. If the data is F, go forward. But now we have a condition. If data is forward and distance is less than 20 or 10 centimeter, then only it has to go forward. This we are doing only with the forward operation, for example. Later you can add too many other things also. Okay. So what we say, when we have two conditions, we need to put and. We need to put and operator. And mean, according to the truth table of the and gate, 00 is 0, 01 is 1, 10 is, sorry, 00 is 0, 01 is also 0, 10 is also 0, and 11 is 1. That means if you have two conditions, both should be satisfied, right? That's what we are saying. If V equals to F, that means if you are writing F from the terminal to move your robot in forward direction and distance is less than 20 centimeter, then only it has to go forward. Correct? Now let's remove all these unnecessary part of moving forward, or let's leave it, but let's remove the part of delay. This is unnecessary part. right? I'll come back. What we have said, first of all, here we said read the value of ultrasonic and print it. Also, let's remove this delay. Don't take 1 second of the time to detect the distance, because when you say robot to go forward and it is going forward and there is object in front of it, and if it detects the distance, it will take 1 second to stop. But meanwhile, delay is there, so meanwhile it may hit your object. So we are not looking for any delays now, right? After this, serial dot available is greater than null. Read the data, store it in a variable v, and here print the same data on serial monitor. So this is not required, that we were doing for the hardware. Now we don't have to print the value of v on the serial monitor. And also close the bracket. Why I'm closing it? Because when you say F, it is continuously going forward. At the same time, we have to check the distance. If in between the distance is changing, it will not check that condition, because the loop goes on continuously. If you don't put the bracket here, that means this condition it will compare once it receives the data from the port. So that means it will check the distance only when it will receive the value F. After that, if the distance changes, it will not identify in between, because the condition is inside this loop. So we need to close this condition so that it can always check the distance. If the data is f and distance is 80, it's going. If the distance is less than 20, then it's not going. So I put a mistake. It should be greater than 20. If distance is greater than 20, that means if the obstacle is so far from the robot, then it can move forward. But once the distance is 20 centimeter, it has to stop. Got it? Now, what we said here, go forward. For backward, we are not doing it. For leftward, we are not doing it. For rightward, we are not doing it. For stop, we are not doing it, right? But we need to add one more condition, because here we said if the distance is greater than 20, then go forward. But what if the distance is less than 20? So we need to write one more case at last. So here we are writing that case, else if distance is less than 20, then stop the robot. And to stop the robot, we already have the condition here, statement here. So let's copy and paste the same statement here. Let me maximize the screen now, because we are done with this part. So let's close it. We have merged both the codes, right? Now I'll remove unnecessary parts which I have commented here, so that it can reduce the size of your program. Also, there is a mistake in the code. I'll tell you what is that mistake. Just give me a moment. I'll first remove all the delays. Although these are comment, but still I'm removing it so that no one can get confusion of what we have done here. Correct. So now we are done. So let's start with it. If the distance is less than greater than 20 and the data is F, it should go forward. It should go backward at B. It should go leftward at L. It should go rightward at R. It should stop at S. And also it has to stop when the distance is less than equals to 20. Okay. And one mistake is what? See, we started the bracket and closed here. So at last, there should not be any unnecessary brackets, because earlier it was we were closing it here, but now we have to remove it, right? So we need to check the brackets. It should be balanced. Else if started here, it is closed. This else if for distance is started here, it is closed. This is the closing bracket of void loop. It is showing you here, right? And other than that, we started this. It is also closed, right? But now when we compile, it will give us the error. I'll tell you why. First, let's generate the error to understand. It would be a syntax error. So P10 and export. See, V was not declared in this scope. V is not declared. Although we have defined the V here as a character, but that V we have defined only for this loop. So it's not working in this loop. Correct? So now we need to remove this char from here, and this is called local variable. Earlier we defined this v as a local variable for only this loop, but now we have to define this v as a global variable. So let's write it on the top and say char v. Now it is global variable. So now we are done with almost all the things. There won't be any errors for now, and we can simply switch to the main. Okay, here we have error, distance, spell mistake. Okay, fine. Now let's come here, upload the code. It's P10. Now let's click play. Okay, unable to open the hex file for ultrasonic. I told you we need to map the file also, and file is available in this folder. I'll share it with you, okay? Because ultrasonic sensor in simulation looking for the hex file, but in reality there is this is not programmable, so we not need to upload any file to sensor, right? So currently the distance is 553 and it is going left side. How it is going left side? Let me check. First we give the command of F. Is it going forward? No, it's not going forward, right? Because it may be because of connections. Because for hardware we change the few pins. We need to check it where we have connected it. So this positive pin, this is the positive pin of motor left positive, and it is connected with pin number PB5. And PB5 is what? 13th pin, right? So let's come to the code and check it. So this might be the error. Yes, exactly. So it should be 13th, 12th, 11th, and 10th. Because we mixed two concepts. We changed it according to the hardware, right? Now we need to shift it again. Problem uploading. We don't have to upload, export only. Okay, compilation is done. Let's click play. Now let's check it. F is for forward. We can see it's moving forward. Then B, it's moving backward. Distance is 551. Okay. If you want to check the values clearly, if it's doing very fastly, I'm putting a delay for you. Okay. Just to understand this one in the simulation. Later we remove it. I already mentioned why we're using this delay so that you can check what exactly your robot is doing for now. Because in this meeting, I do understand that the motor simulation is not visible to you guys. So I am sending the command of small f not working, capital F, it's moving forward, but it took time of 1 second because of delay. Now I said B, it is going backward. I said L, it is going leftward. I said R, it is going rightward. I said S, it is stopped. Okay. Now we have to change the distance. So I said forward, go forward. It's continuously going forward. I'm not changing anything from this terminal, but I'll change from this ultrasonic. So I'll reduce the distance. So I'm saying the distance, do the distance less than 20 centimeters. So now it is 40 and 29 and now 21 and now it is 6.49. So now the distance is 6.49. The command was given a forward. I have not changed anything here, but it stopped, right? It took 1 second because of that delay. Now I'm increasing the distance, removing the obstacle. So if I remove the obstacle, the distance is now 21 centimeters, which is greater than 20. So it's working clockwise and forward direction, right? And if I say manually stop, it stopped. So this project is absolutely fine working, right? There is no problem with this. So now I'll share the whole circuit diagram of this and the code of this, right? Yes. If you have any questions, you can ask. I've shared both the robot with ultrasonic, robot without only ultrasonic. What was P8? This was the code for increasing and decreasing the speed that also I'm sharing. First, let's try to identify the design for this. Yes, this design. So I guess I have shared each and everything. Now, please, if you have any questions. No questions? Okay, then let's switch to ROS. Okay. Uh, Yesterday I told you a brief introduction about the ROS, which is actually not a real operating system. It's a virtual environment we create. Okay. So, although we don't have enough time, the time is already up for the session, but still, I'll do what? I'll try to run one code on the ROS, right? And how ROS is powerful. After this basics of robotics, you will understand using looking at that example. Okay. So for that, I need to open the Linux. So first of all, let me close a few part because when I open the other operating system, it may give us problem because of too much load of the PC. So let me reduce the load. So now I'll open the Linux in a virtual machine. Okay, it's working, right? Now when we are doing the Linux part, so it's completely command-based things, right? We need to remember too many commands also here. And with those commands, we run the codes. And for ROS, you can implement AI and machine learning as well, right? And that too without overload on your controller. So I'll give you one basic example of controlling the robot using the keys of my keyboard. And for that, I'll run two different codes, one Python code and one Arduino code. Although I'm not going to explain these codes for now, right? I'll just show you the example. And other than that, also I'll try if possible because system is too bulky for now. Too many things are running parallelly. If it opens the simulator, what we can observe without a camera, without even a camera, it will show you. If I give the command of going forward, robot going forward, it will show you the same on the simulation screen also, robot going forward. And let me show you. Then we'll discuss about it, right? So first of all, I need to check at which pin. Also, I'll switch my camera. Give me a moment for the robot. See. Now, as we have connected two different operating systems are there. One is your Windows 11, and other one is the Linux. Just so that time, whenever you connect the cable, this will ask at which pin we have to connect. So currently, this is running the previous code, it's increasing and decreasing the speed. We will change it very fastly. So for that, coming here, okay, removing the cable of the bot and connecting it again. So it is asking where to connect the USB device, to host or to virtual machine. So I said connect to virtual machine. Now I need to check at which port it is connected. For that, we have a command ls space slash dev slash tty acm0 acm start. So it will reply back that the port is connected at ACM0, right? Now let's open the Arduino code. As I mentioned, I'll not explain this code, okay? Rather, I'll upload the code and show you the exact output of what we can do with the ROS. A very basic example I'll show you for now. So board is Uno and the port is Dev TTY ACM0. So let's upload the code. It's pin number 12, 11, 10, 9. The code is already set according to the hardware pins. Right, code is uploaded. Let's close it. Now, the very first operation which we have to do while running the ROS is ROS core. ROS core is to start the ROS services. ROS is what? Robot operating system, right? So it's giving us the reply started core services. Now I'll open a new terminal and I'll ask my ROS to connect with the hardware. And currently the hardware is connected with the cable. Okay. So I'll say this command ROS run ROS serial Python serial node and ACM0. I'll say yes, enter it and try to connect with the hardware. So now the ROS is connected with the hardware. Now, let's open the other terminal and there we need to create one simulator scenario that is the gazebo. Gazebo is a simulator of ROS. So I'll try to open that. Also, I want one robot picture in that simulator. So first, let me export the model for that. A turtle robot I'm asking to create a shape of burger on that gazebo simulator. Okay. I do understand this would be difficult for you to understand each and everything right now because we are not doing this part. We have done a basic part of robotics, but this is the next level, and very soon I'll plan hands-on on this also in the same order, like free of cost with paid certification, right? So now let's launch the simulator. Let's see if it works because system is too bulky and the simulator is heavy. It's working. It's working. No errors till now. Yes, it is working and opening the gazebo simulator. And you can see the robot here, right? Now, let's run the Python code, the final code, which we will use to run the output, right? So let's go back to the terminal and let's start a new terminal and run the Python code. Okay. I'll minimize the size of the screen. First, let me run this. The name of the code is, yes, gazebo robot.py. So it is replying, moving WASD, W forward, S backward, A leftward, D rightward, and X to stop, and Q to increase the speed, and D to decrease the speed. Okay. So first of all, let's reduce the size of this. Let's minimize this terminal. Now, what exactly you have to look? Because I have shared the hardware as well as the simulator screen. And from this terminal, I am giving the command. Okay, do remember from the terminal, I am giving the commands of, if suppose I say W, it should go forward. If I say S, it should go backward, A left, D right. The same like we play the games. Okay. And when I'll be saying I'll be running these commands, look at the hardware as well as the simulator, it will also run. Okay. So I say W forward. It's going forward. It's lagging actually, but it's going forward. I say S, come backward. So on the screen, it's coming backward. On the hardware, it's coming backward. I say go leftward. It's going leftward now. I say go rightward. So now it's going rightward. I say go forward in the right direction. So it's going there. I say stop. So it is stopped. So I hope this is clear to you guys, right? And we have used two different codes for this. Let me minimize this. We have used two different codes for this. And ROS is actually a robot operating system which create the virtual environment and communicate between the two nodes using the topics, and we need to create the publishers as well as the subscriber there. Publisher who publish the command and subscriber who receive the command. So in this case, the Python code is working as a publisher where we are writing WASD, and the Arduino board is working as a subscriber. So it can be reverse order also when ultrasonic sensor is also connected with the hardware, and ultrasonic sensor is sensing the distance. Arduino has to provide that distance to the Python code. So that time Arduino can act as a publisher and Python can act as a subscriber. So it's not always fixed that Arduino has to work as a publisher only. It can be publisher, it can be subscriber, depending upon the topics. And topics are what? Topics are basically the concerns, the issues uh, which we want it to identify or to run. For example, when Python code want to know the distance, the concern of the topic is distance, where Arduino is publisher and the Python code is subscriber. And when we are sending the commands of WASD, that time Python code is a publisher and Arduino board is a subscriber. It's like suppose there are two YouTube channels, and channel A and channel B. Channel A is posting the content of the games, whereas channel B is posting the content of say robotics. Right now, it may be like that the content the content posted by channel A is behaving publisher for A. But it may happen that channel B is interested to look at the videos and the content of games. So he is looking at channel A. So that time channel A is publisher and channel B is subscriber. It may be vice versa because channel B is posting the content of robotics and channel A might be interested in that. So channel A is looking the videos of channel B. So that time channel B is publisher and channel A is subscriber. Right. So what is the role of publisher and subscriber is related to the content, the topics which we are creating. And this was the Arduino code which we were running here, right? A very simple code. And then the Python code. Let me show you the Python code also for this. So sometime else we will plan for the hands-on session for this also, right? And then we'll understand how it is working. So this was for W, we set as A, D. And this is the industry grade program which I'm showing you right now. It's not a simple program. It is actually an industry grade program, right? So I am done with the content which we supposed to cover. Now, if you have any questions, please ask. Vignesh, I guess there is no YouTube channel which is training on ROS. ROS is not the traditional one. It's a new technology actually. So currently, in my knowledge, YouTube channel is not available for that. In best of my knowledge, rest you can search. Ronak, I have explained the code of serial communication many times. Can you please exactly mention which part of the code you want to understand now? Because at your request, I have explained it 3 times. Now tell me which part of the code you want to know. I'll re-explain. No problem. Any other questions, guys? Any other problems? Vignesh, how to learn about say you know the basics now, and if you know the Python coding, you can start with yourself as well, or otherwise wait for the next announcement from our side. To follow the LinkedIn channel of company as well as mine. We both post there for these kind of sessions for free of cost. So too many candidates have doubts about the certification, and one was arguing with my teammate. Now he left the session. He said that the certificate was optional. The fee was optional, so it's not like that. Certificate fee is optional. Mean if you want certificate, then you need to pay. Otherwise, you can skip it. Okay, the training is absolutely free. So I am repeating the same thing, that certificate is paid and training was free, which is now completed, and we didn't even ask anyone to pay for that, right? And let me also tell you, because I don't know you were there in the session of PLC or not, because we conducted one session of PLC also, and almost 1300 participants were there, although joined a very less number. They that time also I announced the same thing, that we will do few trainings free of cost if we get the feedback, good feedback. And feedback not in terms of only free trainings. We also want the benefits of paid certificates, which we are raising the funds for social cause, right? Because this small amount is not going to help company, not even going to help me. This is for the social cause we are doing in a city where we are living. So for that, we are raising funds by doing these free certificates, sorry, by free trainings with paid certificates. So again, I'm repeating the same thing. This the amount which you are giving for the certification is completely for the donation for the social cause. Right. I guess no one has the doubts related to the technical questions now. So I guess we should wind it up. But before we go ahead, I request each and everyone to please turn on the camera for a small screenshot, for a record. I'll also switch my camera. Please, everyone, do it fast. I'll also put one robot background. Simple example, what we have done. This is good, right? Guys, turn on the camera fastly. Or do I need to stop sharing my screen? Only two candidates. Okay, let's click with you guys only. I'll post it on my LinkedIn. So you two are lucky for this. Cheese. Okay. Thank you. See you soon in the next session. If I do get time, I'll post it. Thank you so much, guys. Have fun. Bye bye. Take care.